try as much as possible to mute your device. Okay, so let's start with our class for today. I'm going to take you through section 1. Okay, section 1, we are going to talk about a review of linear algebra. This slide is on Sakai, so you can get it and review it or go through after our class. On that note, I expect that at the end of this section, students should be able to know what a matrix is, or to be able to define matrices. You need to understand the properties of matrix and go further to do some matrix operation, i.e. addition, subtraction, transpose of matrix, multiplication. You should be able to perform these operations. Then again, you should understand what we call an identity matrix and the inverse of a matrix. Then, can we use matrix to, or can we transform a set of linear equation into a matrix form? Then if we transform set of linear equation into a matrix form, how do we solve it? So you need to be more familiar at the end of the class with matrix operation and how to transform set of linear equation into a matrix form. Very, very important. So we can find this session in the first textbook, Winston and Goldberg. So when I submit the reading list or the soft copy to your course rep, please go to chapter 2, and most of the discussion we are having now, you see them in Winston and Goldberg textbook. So what is a matrix? My dear friends, matrix simply, we are looking at how we can arrange some set of numbers, okay? And that arrangement, if we do it in a rectangular array, then we can call that set of arrangement as a matrix. So a matrix is any rectangular array of numbers. For example, you can see that I have this set of arrangement, that set of arrangement, and this set of what? Arrangement. All these arrangements represent matrix. So let's say that this is matrix A, matrix B, matrix what? C. This arrangement, then based on what we have, we can now have to identify specifically rows and columns. So for each matrix that you have, identify the row and the column. Then once you do that, you'll be able to know the number of rows and the number of columns. So if I have 2 and 4 horizontally, this is a row. 4 and 6 is also another row. 2 and 4 vertically is a column. 4 and 6 vertically is what? Column. So I can say that I have 2 rows and 2 columns. Then when I come to matrix B, again horizontally, 2, 4, 3. This is row 1, 5, 4, 6, row 2, 6, 1, 8. This is row 3. Again, I have 2, 5, 6, column 1, 4, 4, 1, column 2, 3, 6, 8, column 3. Same happens to this. So this one is what? Row 1, and I have what? Column 1, column 2. This number of rows and number of columns would help us to define what we call the dimension of the matrix. So every matrix that you formulate should have a dimension. And by dimension, you are looking at the number of rows and the number of what? Columns. So for example, if I have these matrix, okay, All the numbers that you see in this matrix are called elements. So as we have here, all 2, 4, 4, 6, they are elements. Each element belongs to a row or can be found in a row and a column. So that if you come here and I have an element A at this area or this space, I should be able to tell which row and which column I can find the letter A. Okay, and we've agreed that these are rows, and these are columns. So I can say that A can be found in A11, row 1, column 1. Again, the next A can be found in where? Row 1, column 2, all the way to A again can be found in what? A, that's row 1, column what? N. Means that for all the elements here, we should be able to detect their rows and their column. Then I can come and define the dimension of that matrix. So by dimension, we are saying m by n. M by n means that row by column. So what you can see here, as we've defined here, this first example, this matrix is a 2 by 2 matrix because row 2, column 2. This is what? A 3 by 3 matrix, and this is 1 by 2 matrix. So by way of defining the dimension, please pay attention to the number of rows and the number of columns. So to explain or to summarize, we are saying that the number in the ith row and the jth column of matrix A is called the ijth element of A, and it's written as what? Aij, where I is the row, J is the column. So, for example, if I have these matrix, let's say it's matrix A, I should be able to tell the rows and column for each of these elements. So if I say the number 8, it's found in row 3, column 3. So I say A33. Okay, who can help us with the number 5? Which row and column can we see or can we identify 5 with? Which row and column can we are 45 here, so today we should have a proper discussion, guys. So how do you
row 2, column 1.
It's where row
2, column 1.
Row 2, column 1. Perfect, Jennifer. What about number 1? The number 1. The number 1, who can help? The number 1.
Row 3, column 2.
Row 3, column 2. So that is all we are looking at. But then these are just the elements. We need to know the dimension of the matrix. Element can be found in the rows and column, but the dimension, so the dimension of this whole matrix is what? A 3 by 3 dimension, because number of rows are 3, number of columns are also what? 3. That is perfect. We can make progress. Good. So we can have some special form of matrix in the form of what? Vectors. Okay. Basically, they are looking at just a number of rows and one column. Okay, so that's why we see that we have n by 1 dimension matrix rectangular array. So this is an example of a matrix in the form of a vector. So we say the vector of the form V is a column vector. Okay, the transpose of the column vector is a row vector. We will talk about transpose very soon. Then because you can have these two-dimensional vectors, which at the same time we can refer to them as matrices. We can do direct a line segment in an m-dimensional plane. So that's to say that you can plot them in a form of what? A graph. So vectors are a special form of what? Matrix. These are some of the operations that we can perform as far as matrix is concerned. And the first operation that we can perform, or one of the operations that we can perform, is scalar multiplication. By scalar multiplication, all we are interested is that for any given matrix, we can multiply a certain number by the matrix, and that number is what we call a scalar. So usually we say a non-zero scalar, okay? So given a certain matrix and we are multiplying by a scalar, all you have to do is to pick the scalar, multiply through all the elements in that matrix. For example, if we have matrix A here and we have scalar 3, and we are saying that we should multiply scalar 3 by matrix A, I'm only multiplying scalar 3 by all the elements in the matrix. So what you see is 3 times elements here, 2 is 6, 3 times 4 is 12, 3 times 3 is 9, 3 times 5 is 15, 3 times 4 is 12, 3 times 6 is 18, and 3 times 6, that is times 1 times 8. So we have 18, 3, and what? 24. This is scalar multiplication in simple terms. So just take the scalar and multiply it by all the elements that you have in that scalar. Stephanie, do us a favor to mute yourself, please. Stephanie, mute yourself. You are making noise. Thank you very much. All right, so this operation is simply called scalar multiplication. Then the next operation we can perform is addition. We can add matrices, okay? You can add matrices. But what you should know that you can add, whose hand is up?
Sir, please, kindly go over the scalar multiplication. I missed something.
You are only multiplying the scalar by all the elements in the matrix. That's what we said. So if I have, what do I have here? Let me pick. If I have a matrix B giving us 4, 3, 2, -1, 2, and 3, and I have a scalar 2 to multiply, okay, it's just to say that 2 times matrix B, and that will give me 2 times the first element. 2 times 4 is 8, 2 times 3 is 6, 2 times 2 is 4, 2 times -1 is -2, 2 times 2 is 4, 2 times 3 is 6. What I've done is scalar multiplication. I hope that is clear.
Okay. Yes, please. Thank you.
So let's go to the next one. We are saying we are doing addition. Okay. And by addition, the first condition is that before you add 2 or more matrices, make sure their dimensions are the same. Means that M by N for matrix A should be the same as M by N for matrix what? B. Okay, the dimension should be the same. If this is 3 by 2, this should also be 3 by 2 before you can add them. That is a condition you need to pay attention to. So that if I have matrix B and I have matrix C here, 2, 1, 4, 2, and I want to do B plus what? C. It says that their dimensions should be the same. This is a 3, 2 by 3 matrix. This is a 2 by 2 what? Matrix. I cannot add matrix B and C because their dimensions are not the same. Please note that for addition, ensure the dimensions are the same. So if I have matrix given as 1, 2, and 0, 9, between B, C, among these three, which matrix, which of them can I add? I can
C
add,
and D.
I can do what?
You can add C and D.
C and D.
And D, because their dimensions are the same. How do we add?
The same.
I'm going to
Yes,
add. If you have a question, don't interject me. If you have a question, raise your hand. I'll call you. Okay. Let's have a decorum. So by addition, I'm going to pick. You don't just add anyhow. Okay. We are adding rows. So if I pick the first element in matrix C, I have to add it to the first element in matrix what? D. If I pick the second element in matrix C, I have to add it to this guy here. Then I pick this one, add it to this guy here, add this one, and add. So the positioning of the element matters in your addition. So I'll have 2 plus 1. Then I'm going to have 1 plus what? 2. The next one is what? 4 plus 0. Then 2 plus 9. This should give me 3, 3, 4, and 11. So matrix D, C plus D equals to 3, 3, 4, 11. That is how you perform the addition. So please note, after you've identified that their dimensions are the same, the next thing you do is to add each element with respect to the other element in the other matrix. So that you don't just say 2 plus 2, 1 plus 4. No, no, no. Do the addition by way of what? Row addition. Please note that. Okay, so if that is clear, let me go to the next one. Or if you have any question, ask quickly so I can move to the next one. Okay. If you don't have any question, the next operation that we can perform is multiplication. Okay, multiplication. And by multiplication, we are also looking at just multiplying matrices. Okay. Also, there are conditions you need to satisfy. The first condition is that for any given matrices that we need to multiply, we first of all have to ensure that the first matrix, the number of columns for the first matrix, let's say matrix A, is the same as the number of columns for the number of rows for the other matrix. Means that if I have matrix A multiplying matrix B, I can only multiply them if the number of columns for matrix A is the same as the number of rows for matrix what? B. Then I can go on and perform the multiplication. That is the first thing that you have to understand. So that if matrix A is 2 by 4 and matrix B is 4 by 1, the question you ask yourself is that, can I do this operation? Because we say that the number of columns for matrix A should be the same as the number of rows for matrix what? B. Because they are the same, I can perform that multiplication operation. But if I have 2 by 3 and I have 4 by 2, this is matrix A, matrix D. I want to find A times D. I cannot perform this operation because the number of columns for matrix A it's not the same as the number of rows for matrix what? D. Guys, this is the first caveat that we need to observe before we can do matrix multiplication. Are we here? I can't hear you. Can you hear me, guys?
Yes,
Yes,
sir.
please.
Yes, sir.
Okay, so thank you.
Exactly.
All right, so that is the first condition you need to ensure before you can perform the multiplication. Once this is done, you can go ahead and do your matrix multiplication. I need you to pay attention here so we can do this together, okay? So let's say that given that, hands up, if your hand is up, I can't pronounce your name. What name is
Sir,
that?
can you please?
Yes, who is asking the
Sir,
question?
can you please use a black?
A black marker.
Sir, can you please use a black writer?
What about
Yeah.
red? Red should be fine.
Yeah, sure.
Okay. So let's pick an example and solve it and do the multi. If you have a question, Stephanie, go ahead and ask. Hello. Okay, so my friends, let's pick an example for the multiplication. Okay, so let's say that I have matrix B giving us 2, 2, minus 1, and 4. Matrix C is also giving us 2, 1, let's say just 2, 1. Let's look at this. This is a 2 by 2 dimension, and this is what? A 2 by 1, 2 by 1.
Please, I can't hear you.
My friends, can you all hear me?
Yes, sir.
If you cannot
Yes, sir.
hear me, who
Yes,
said
sir.
Irene? I think you should check your system because majority of us can hear.
Sir, please, we can't hear you now.
Please, we can't hear you. I think you need to unmute your speaker.
Okay, can you hear me?
Yes,
Yes,
please.
sir.
Oh my goodness. All right, so I'm saying that we can perform multiplication for B and C because the number of columns for B is the same as the number of rows for what? C. Then how do I perform the multiplication? We are going to pick, literally, let me just say that you pick row 1 and drop it on column 1. You pick row 1 and drop it on column 2.